Good morning, one and all. Welcome to the second day of 10th International Conference on Advances in Computing and Communication 2021. Today, we start off with the keynote session led by Dr. Peter Stadstis from Australian National University, who will give an overview on the topic, the space grid combination technique and for resilient extreme scale simulation. I request Reverend Dr. Jason Paul Mulavarica, CMI, to introduce and welcome our keynote speaker for the day.
Good morning, Dr. Peter Stadstis and my friends. It's a great pleasure for me to introduce Dr. Peter Stadstis to the conference and to the audience today. I can see him over there, and it is a very pleasant surprise. He is an associate professor at the Research School of Engineering Computer Science in ANU. And more than that, personally, he was my PhD guide at ANU. And I'm very happy to see Peter over there, at least on the video screen today, and we can jointly participate in this conference. I have got very fond memories of working with Dr. Peter. I worked under him for nearly 5 years. And one thing I've always noticed, he had time. He had time to give to their students. And I still remember almost every week, he would spend at least 1 hour with me as a PhD student. I don't think that so many guides would do that. And another important thing is he is quite knowledgeable and he has got a lot of hands-on experience. And he will work with me over the codes, which I have never seen from a guide or I've never heard from a guide who is doing that. And only because of him, I could complete my PhD in time. And here I am at Rajagiri after all those toiling years. And today he will be presenting before us some interesting topics, and his area of interest are parallel programming and high performance computing, which I'm pretty sure he will handle very earnestly. And he also has got interest in large scale simulations, visualization, virtualization, then resilience for HPC, computer modeling, and performance analysis. So I welcome Dr. Peter to this conference and to deliver this keynote session. And I invite him on behalf of everybody. Thank you.
Thank you very much, Professor Dr. Jason. I must say it was a pleasure supervising you as a student. I'm unfortunately in Canberra today. I really would very much like to be with you in Kochi, but I hear you've had some very terrible floods, and I hope that you and your loved ones have been saved from them. In Canberra, we still have lockdown now, which is a bit of a nuisance, but in a few weeks' time, that will be gone. Well, I'll share my screen and get on with the talk. Oh. I can't share my screen. Can the host do something about that?
Yes, sir. 1 second, please. So can you please try again?
Still says the host disabled participant screen sharing.
Please try once again.
Good.
Yes, we can see that. We can see.
Good. Okay, so I'd like to talk to you about a project which came after Professor Dr. Jason left the university, and it was in collaboration with a PhD student of mine called Mitigation and a PhD student in mathematics at the time called Brendan Harding, and Marcus Headland, who is also an academic in engineering. And this is a project that was between two disciplines, and the combination of the techniques from two disciplines created a new thing. Now, my slides are up on my personal webpage here, if you want to refer to them. And you may have noticed that innovative computational methods is one of the themes of the conference, and the sparse grid combination technique fits in very well with this, because it's a technique from applied mathematics, a state-of-the-art technique, and it's not just a sparse grid combination technique, it's a robust version of it that we used. And we combine with various things from parallel algorithms, resilient middleware, and application refactoring to do the thing which has never been done before, to make extreme scale physical simulations both faster and resilient. And we're talking about real world applications here. So it makes them faster, and it also makes them fault tolerant. And this is important, as we'll look at in the next slide. So this is I saw here, that's Mitigation, the lead author of this paper. And we made the gene gyro connect plasma application fault tolerant for the first time. So Machine's work was basically to do the application refactoring and dealing with resilient middleware. This is Brendan here. He's holding one of the certificates for the Outstanding Paper Award. His work was to do the robust part of the robust sparse grid combination technique. My part was to do the d-dimensional parallel algorithms. And this is Marcus Headland here. And his part was not only to just supervise Brendan, but to he conceived the idea in the first place and led all the research. So this is what I would call an example of innovative computational method coming across from two disciplines and doing something for the first time. Okay, a quick overview of the talk. Why are we interested in fault tolerance, since you probably are not all convinced of that? How we basically use a sparse grid combination technique to solve partial differential equations, a variant of the sparse grid combination technique with the hierarchical surplus representation. And then we'll go straight into the parallel sparse grid combination technique algorithms. And we first have to look at how to do the mappings for block distribution in a d-dimensional space. We'll look at the first algorithm, which is called the direct SGG algorithm, and its basic ideas and its limitations. Then we'll look at the algorithm based on the hierarchical surplus representation, which we'll look at in the background. And two issues are forming surpluses and then coalescing them. Then we'll look at some analysis and experimental results. Now, this is the second part of the talk, and it's actually using what we've done so far to make the actual applications fault tolerant. Well, to make it fault tolerant, we have to have failed processes and we have to restart them on other places. and this is user level fault mitigation version of the message parser interface that we use there. We'll look at the general methodology about how to make the applications fault tolerant, and then we'll look in details at 3 applications: gyrokinetic plasmas, lattice Boltzmann, and the solid fuel ignition. So why is fault tolerance becoming important? And exascale computing, we have a very large system with n components, where n is very large. The mean time to failure is proportional to 1 on n, and this is a basic law. You can make the constant of proportionality a little bit different, but you're basically bound by this relationship here. So that means that a very long-running application will never actually finish. It will always keep failing. When you restart it again, it'll fail. It'll fail again. So the failure is mainly what we call a hard fault, which is where a node either has a software error and temporarily crashes, or has a permanent failure. Now, in cloud computing, there's a variation of this and of resilience. And it's basically a situation where you have varying costs for your compute resources. And when the resources are high, you'll probably want to use few of them. And when it's cheap, you want to use many of them to get the best price for performance for your computation. So that's called elasticity, and this is very closely related to fault tolerance. Finally, we've got the adverse operating conditions, where the components may become faulty, and typically we'll get a corruption of memory, a bit flip in our memory, and we'll get what's called a soft error. So the computation will continue, but we'll be going along with possibly with the wrong data. So there are the 3 kinds of fault tolerance that are. In this talk, we're mostly interested in the exascale computing version. Okay, so this is sparse grids, and I'm sure you're familiar with normal grids, where you have basically a rectangular set of points, and you have your field, your solution being evaluated on those points. Well, if you have the regular grids and you've got the power of 2 plus 1 number of points in each dimension, then you've got n to the d points in all your dimensions, and you cannot usually get very high d without this causing scalability problems. And this is known as cursor dimensionality. So the idea of sparse grids, so here we have high resolution points everywhere, but here we only have half as many points. Here we only have a quarter as many points, and there we only have an eighth of many points. So we have some fine scale resolution, but the majority of the space is quite coarse scale. And what's interesting about this sparse grid is we can construct a sparse grid from a series of regular grids, as we'll see in the next slide. Now, because we have fewer number of points here, we can evaluate our computation over this grid with much greater computational efficiency. So we'll now look at how we can use the combination technique, and this is where we approximate the sparse grid with a set of coarse grids. So consider this diagram here. Here we have 3 rectangular grid. We have low resolution in the X dimension here and high resolution in the Y dimension. Here we have medium resolution in both dimensions, and here we have low resolution in the Y dimension and high resolution in the X dimension. Now here, the grid has got 9 points. That's 2 to the 3 plus 1. And across here, it's got 2 to the 1 plus 1 points. So we can use the index 3, 1 to represent this grid. So that's 3, 1 means 2 to the 3 plus 1 across the x dimension, and 2 to the 1 plus 1 across the y dimension. So correspondingly here we have grid 1, 3, we have grid 1, 2, grid 2, 1, and grid 2, 2. Now, if you combine all these grids here, you get the sparse grid at index space 3, 3 here. And to combine them, you need some kind of interpolation, which we see can cause some problems. So in this diagram here, we have the 3 by 3 case down the bottom here. And here we have a 9 by 9. So the sparse grid is a grid index 9, 9 right up here. And the combination of these, we add the ones on the main diagonal and subtract the ones on the off diagonal to give you the combination or the approximation of the sparse grid. Okay, so that's not yet robust. So how do we make it robust? And the idea is simply to give you another set of diagonals here. If there are no faults, we don't use this other set of diagonals. And notice that the extra points we introduce here is actually very small, because as you go down the grid index space by 1, you halve the number of data points. But if we have a fault, then here, then what we can do is we can use this grid on the third diagonal here, combine it with this one and this one, and use the others as before. And our solution will lose a little bit of accuracy, but it will be more or less valid. So we can have a fourth diagonal too, which covers all possible cases of failure. And what happens is that once we have a failure here, we can recover the data by doing the combination, and then we project the combination back down to this grid to get the data there. Okay, finally, we'll look at the hierarchical surplus representation of grids. So this is a nodal representation of a function here, and these distances here represent the function as you would normally represent it. But what we can do with a hierarchical representation is we subtract the average of the points on either side at a power of 2 distance, and instead store that amount. Now, the advantage of it is that the number of surpluses in ij is I times 1 plus j plus 1, and the surpluses the surpluses corresponding to the upper diagonal here, they are unique and you don't need to communicate them. Okay, so this is how we form the hierarchical surpluses. To form 3 naught, we take the neighbors on either side and we take the average there. And for the index 2, we take distance 2 each way, and the index 1, we form it at distance 4 each way. So what we have here is that this is our original grid elements, and this would be the hierarchical surplus that this element would correspond to. So this element would correspond to 0, 0. This one would correspond to 3, 0. This one to 3, 3, and so forth. So we can do this in place. And if you look at, for example, surpluses 1, 1, you'll see that there is only 1 point there, and that is independent of how big this value of I here is. Okay, so now we're coming into the sparse grid algorithm, the gather scatter idea. So what we have all around the edges here component grids like we have here. And these are distributed over process grids. So this component grid 3.3 is distributed over 2x2 process grid here using the block distribution. And the component grid 4.2 is distributed over a 1x2 process grid here. So what we do is we evolve this simulation a certain number of time steps, all of them, and then we form a combination. And what we'll do, we'll send them to another set of processes here. This is a 2x2 set of processes, and the corresponding points from each region go on each of these processes. So that's the gather. Then we do the combination with interpolation. And then what we then do is we then project this sparse grid here, which is at grid index 5.5, we project it back down onto 3.3, 1.5, 4.2, and all the others. So this is the basic idea of the algorithm. Well, to express this algorithm, what you need to do is come up with the right notations. And we're basically dealing with small vectors. For example, the sizes of our grid, or the size of our process grid will be a small vector. And we'll define some vector operations. So the vector m is less than or equal to m if the x and y components are both less than or equal to others. We can define the product of the vectors m and m as the element-wise product. And we can have a reduction on n. In this case, it basically means that we take the product of the individual components. Now, if we have the scalar a, we have a similar kind of thing. We basically promote a to be a vector. Okay, so we've got our grid size n, which could be like 26 by 26, and would be over process grid p, which would be something like 2 by 2. And the index of a process would be something like 0, 0, and 1. It has to be less than 2, 2. And if we have a global index n hat, then we can define the local length using this vector notation here. We can also define the global index of element 0 in process P. And we can find the actual process that index n hat is on. And finally, we can work out what the offset within that process corresponding to n hat is. And these are the essential things that you need to express these algorithms. Okay, so basically what we're going to do in this algorithm, we're going to iterate until we've exhausted our local number of elements, and we basically work out the process P dash where we'll be starting to, and the offset in that process we're first sending to. So inside the loop, we work out the corresponding offset for this iteration, and it's basically where the starting indexes are 0. We find out the actual length on the destination, and then we can work out the number of points on our size here, and then we can send those points to that destination, and we update the starting indices and the process IDs. Well, you're probably not convinced that this is actually correct. It's not easy to work it out, but the point is that with the right using vector arithmetic representation of this algorithms, and the use of these mappings, you can actually solve in a reasonably succinct way this algorithm. Okay, the receiving part is quite similar. We'll have a similar kind of loop, but we'll have to iterate over all the components grids, and when we receive, we'll have to interpolate. Okay, so that was the gather stage. The scatter stage is similar, but it's in reverse. And instead of interpolating when we send, we downsample. As mentioned before, if we use 3 or 4 diagonals or component grids, we can achieve a fault-tolerant sparse grid combination technique. And in the process where it fails, we basically put a 0 from the combination coefficient, so it doesn't participate. But apart from that, the algorithm isn't affected. Okay. So the grid that we do form the sparse grid on P dash, its components must be all powers of 2. And we have currently we support up to 3 dimensions in this. And the main problems with increasing the dimensionality is you have to actually enumerate all the grids, which gets very complicated in larger number of dimensions. You have basically slices, triangular slices in hyperspace. And the interpolation function also gets complex. And the final point is that when we do the gather on this, we're not doing it on an actual full rectangular grid because that would not be scalable. We're doing it on a sparse data structure. Right. So the alternate algorithm, hierarchical surplus-based algorithm, and here we have a combination of these grids in yellow here, and these each little square here represents the individual hierarchical surplus. Okay, so we hierarchize each component, and that's basically similar to a stencil in terms of complexity. And over each surplus, we can then apply the direct sparse grid combination algorithms to it. Okay. The advantage of it, we don't need to have an interpolation. And then finally, we unhierarchize to recover the original grid. Okay, so what we can observe is these hierarchies here on the edges here, they're only in one set of processes, so they don't need to be communicated. And that's the advantage in reduction in communication bandwidth. All these processes here in this rectangular box here, they're all on the same set of processes, and they can all be done at once rather than individually. And similarly for the others here, and this big rectangular area here, that can all be done at once as well. These hierarchies here must be done individually, these ones in here. However, we can do this one and this one in parallel because they're operating on disjoint process sets, and then this one and this one in parallel. And finally, we can do the ones with 3 in parallel too for the same reason. All right, so analysis. We've got the typical operating conditions. The process of the sparse grid, what we can do, we can reuse the processes of the component grid for that purpose. To make the analysis simple, we're going to assume that the process grid size are all powers of 2. And basically on the lower diagonal grid, we allocate half as many processes because it has half the meeting point and therefore has half as much work. Okay, so if G is the number of grids, then basically we've got less than or equal to G messages, and we're not going to receive more, each one not going to receive more than 2 endpoints because P dash could be half the size of all the PIs to begin with. So the time is going to be 2G times the communication startup time alpha plus 3M times the communication word per word cost beta. So for large M, it will scale fairly well, but not so much as large G. The hierarchical one, we avoid some communication of the surpluses, but we have many more startups and we don't have a full parallelization and we have some load imbalance. So we don't expect it to be performing quite as well. Okay, so some performance results here. So we've run a vection simulation 1,024 time steps, and we've got 1, 4, 16, and 64 combinations, and basically the extra combinations slow down the grid, but we can still see that the application is scaling. And the non-blocking send versus the blocking send, the non-blocking send generally performs significantly better as well. Similar kind of things for 3D. Now we'll just look at weak scaling here. So what we wanted to see is something that's actually rather boring, which is a whole lot of flat lines laid down on top of each other. We want the lines flat across the horizontal dimension because we want to, that means it'll be scaling with the number of cores. And we want it flat on top of each other vertically as well, because that will mean that as we increase the levels, we're not introducing scalability problems. Okay, so with the direct algorithm, the dashed lines are the interpolation, and the point to note is that a significant amount of time is spent in interpolation, even though there's no communication there. But the lines are basically flat, and they're not very far separated. We see with the hierarchical surplus algorithm, these points are here for the hierarchized and unhierarchized part of the function. We can see that that's not very significant. The main thing is in the combination algorithms, and we don't see as ideal scaling process behavior either horizontally with number of calls or vertically with increased levels. The 3D performance is a similar kind of story. Again, the dashed lines here are the interpolation only component. We can see that's significant, but we have generally flat lines which aren't too far separated out here. This line here is all these measurements are done with a warm-up, and if we don't do a warm-up, we end up with points right up here, and this is due to the NPI creating new process connections. It's a one-time cost, and it's something that you have to be aware of when you're doing these computations. But it doesn't appear in these ones because they've been warmed up. And the hierarchical surplus, again, we have these 3 plots here for the 3 levels, and you can see that it doesn't quite scale as well. Okay, so now we're moving on to the second part of the talk. So here we have a processes with a set of 7 processes here, and processes 3 and 5 fail. Well, what we can do is we can create 2 more child processes, possibly in a different place. And we can merge the two IDs to get this. But the problem is that we haven't basically got the same processes. So we have to re-rank these processes here, and we have to reorder these ones here to basically get the original processes here, plus the two fresh child processes 3 and 5. So in user level fault mitigation NPI, this is how we do it. We attach an error handler to a function, saying that if any NPI function calls, we call a particular handler. And in our handler, what we do is we revoke the communicator, and then we shrink it, and then we use the group difference functions to get a consistent view of the processes. And this is a non-trivial thing. And then we have to translate the ranks. Finally, we have to spawn the required number of file processes and then merge them again. And finally, use a distributed agreement algorithm to decide on, so we decide which processes are which. Okay, so that's process recovery. Data recovery is done as the way we've described before. Basically, we reconstruct the processes before we do the combination. The new processes do not participate. They have a combination coefficient of 0, and we apply the combination technique, and these new processes receive the downsampling of the combined grid. Okay, so that's how we recover, and that's the reconstruct faulty communicator function here. So the general methodology of making an application fault tolerant is we basically get a set of subgrids. We keep a track of those. We have a set of sub-communicators, and W is a global communicator like MPI Comworld. And we also have a set of fields returned by the application, and we also have the corresponding set of subgrid solutions here. So we basically initialize the subgrid solutions to be null to force the run application to initialize the grids from the initial conditions here. And then we copy over the same points on the subgrids, and then we update the boundaries. So the update to boundary is needed because of interpolation. And then we check for failures. If we have failures, we reconstruct the faulty communicator, and if necessary, adjust the combination coefficient. And then we do the gather and the scatter for the combination technique. Okay, so now we can look at the gene application, and it's basically finds microturbulence, which is a very important thing for fusion. So we have X in the radial space here, X in the perpendicular space or Y, and Z in the parallel. So basically we have this big donut shaped structure here with fields going around the donut here. And we have the velocities in the perpendicular and the parallel directions as well. So it's a very highly developed application, quite complex, and it's also very scalable. And also we've already received good results on the sparse combination techniques. All right, so to incorporate in the gene, there's basically a density field. And viewed as double precision array, you've got two for each complex number, the number of points in the X or the radial direction, number of points in the Y or the parallel direction, number of points in the perpendicular direction, number of points in the Z or parallel direction, and the number of points in the vertical velocity, perpendicular velocity, and the number of points in the parallel velocity. So we have more dimensions in our field here, but we only need to, we can apply to any three of them. So, for example, if we want to do it on the V and U dimensions, these two here, we make, instead of a single element, we have a block of 2 NX, NY, and NZ elements here, make up a single component for the sparse grid combination technique. And we also have to do padding from 2 to the n to 2 to the n plus 1 for the sparse grid combination technique as well. And some of the work I did was to work out the shift for the Z direction, which is a boundary condition, which is a little bit tricky because you have a torus chasing itself there. Okay. So what happens is that you have all these different directories, one for each process grid, which needs their own parameter files. And we had to do a number of other small modifications to the code to be able to support the combination technique. Okay, the performance, if we have a look at this, the full grid is the blue and the orange here, and these points here are the sparse grid techniques. And you can see that these are significantly faster, basically because we're doing much less work. Now, our general strategy for the combination technique is to balance work across the grids, and the uppermost diagonals get twice as many points as the next diagonal. And this is basically because we have twice as many points on the upper diagonals, and they therefore work. However, this is only a first approximation. And we noted in this diagram here, we have this group of 8 processes here that finish very early, whereas these groups of 8 here finish much slower. And there is scope for actually improving this, and in taking some processes away from this grid and perhaps give them to the other grids. Okay, the accuracy. So this is the accuracy compared with a full grid simulation and relative one norm error. And one thing to notice is that the accuracies are probably fairly acceptable, or less than 2 to the minus 3. And if we perform multiple combinations, we actually get a reduction in the eventual error, which is an interesting thing. And similarly for the 3D. Okay, with the visualization is another way of looking at accuracy. This is visualization of the field, and with the combination without failure and the combination, they look more or less identical. Okay, so with fault recovery here, we compared with checkpoint restart, seeing where it was quicker. Here we have the component time for checkpoint read and checkpoint write down there on the Ryzen supercomputer. And he somewhat greater is the process recovery. However, we do see that the overhead of the fault tolerant SGCT is significantly less than the checkpoint restart here. Okay, so Taxonomy out of Boltzmann is an open source, highly widely used code as well. And we use a bubble test where we have some miscible fluid forming a bubble inside the other. Now, we had a small number of changes to the actual test program itself, but nothing very significant. And we see a similar kind of improvement over the full grids here. We're doing significantly less work on the sparse grid, and we're getting the increase in performance there. And with the visualization, this is the initial conditions, this is the full grid, and this is the sparse grid combination over with various errors introduced, faults I should say. Now we do see some artifacts being introduced here, which is a bit unfortunate, but apart from that, we see the overall picture is more or less unchanged. Finally, we're getting on the solid fuel ignition application. And this is also a very highly developed application. And again, we had to do a small number of relatively minor modifications to the code to incorporate the sparse grid combination algorithm. Okay, so we see quite a substantial difference in between the full grid and the sparse grid in terms of computation time, both this one and the red and the blue one. So we're getting 9 times faster in 3D basically, and we're getting a very high number of accuracy. So the sparse grid combination technique is working very well in this problem. And this is a visualization. This is the final field, and we have the field after the combination and with various grid failures, and we can see that they're to the eye identical. Okay, so conclusions. So we can get good accuracy performance trade-offs with sparse grid combination techniques, provided we choose the right simulations. And for a very modest amount of extra computational costs, we can make it fault tolerant. And we have the user level fault mitigation Npi as the infrastructure that we're required to support this. So these were the first fully parallel sparse grid combination technique algorithms, and they were developed at 2 and 3D. We managed the complexity of the algorithm by using a vector arithmetic description with various mappings for the block distribution. The direct algorithm needed a sparse grid to interpolate it on. That was important to ensure that it stayed scalable. And another important technique for the hierarchical surpluses was to coalesce the hierarchies. So the direct algorithm is faster, and recommend that you stick to this, and the grids are basically for relatively small number of dimensions and number of levels. So relatively small number of grids, in other words. And the code is available too. Okay, on the application side, we've come up with a general methodology and with a lot of source code applications. And we got very good speed ups and for acceptable loss of accuracy in gene. And we noticed the model's fast grid combination techniques reduce the actual error from failed grids. Okay, the recovery time is favorable to checkpointing, so it's a good alternate technique to use than checkpointing, and our system is generally quite robust. Okay, so future work, we start failed processes on the same node or separate node, usually a separate node. We can also shrink the process, so once a process fails, then we just simply shrink the process grids. The advantage of that, the sparse grid combination technique is algorithm is basically a data distribution, and the redistribution that you have to do is basically zero cost. We have done some work on that. There's plenty more work to be done on it. Okay. Look for other applications. The solution has to be smooth for the sparse grid combination to be effective. We can't have discontinuities. And to extend it to higher dimension is another idea of future work. And I've actually had a master student, CU, who's actually done a very credible task to create a 4D version of the codes. Soft faults is another possible thing to handle this for the algorithm. You have problems like smearing, and it's not clear how big areas that you have to combine point-wise to destroy the error. And the hierarchical algorithm will have an advantage here because you've got the common information is all in one place. Okay, and finally, it's more challenging in terms of time and memory are going to be likely. Okay, so that's my talk. Are there any questions or comments? Hello?
Hello, Peter.
Yes.
Hey, thank you for the nice presentation and the good work that you still continue to do at ANU. And I was just looking at the tables, and I could see it's really memory consuming, isn't it? Like in one of the graphs, I could see the memory consumption is something like 10⁻⁴ GB. That means 10,000, is it? Gigabytes of memory that is consumed by, I suppose that is for nearly 2,000 cores. And you said that we are getting ready for the exascale computing. So if you are looking for the exascale computing, I think that is justifiable. But for a program, for a routine like the gene, is it justifiable? What do you think? Can we actually reduce the memory consumption as we go along, maybe in the future work?
Right. Well, the memory consumption is largely due to the application itself. We're running very large simulations, and the graphs showed that the sparse grid combination technique didn't give you any extra overhead than the full grid, which is its basic alternative or its baseline. So we'll only, and you have to remember that this was also the aggregate memory. So this is aggregate over all the cores. So yes, these simulations are for very large exascale systems. That's mainly what we're talking about. But I don't think there's very much that we can do about the memory. If it's simply because we're running these very big simulations.
Thank you, Peter. And also one more question that is regarding the fault tolerance. Some of the techniques that you used, I really like with regards to MPI. But I think in the very beginning you mentioned maybe this principle could be used in cloud computing in some scenarios. Did you make that mention? Is it possible, or is there any application in cloud computing?
Yes, so in cloud computing, there is a concept called elasticity. And in terms of the number of resources that you use, you want to be able to, if the conditions are changing, like the cost for a compute node per hour is changing, you need to be able to reduce the number of nodes that you use. And if the cost then reduces, you then want to increase it. So this is just a related technique to resilience, or a related idea to it. Of course, it would be an interesting thing to try and get the sparse grid combination technique working in an elastic scenario.
Thank you, Peter. Have you ever tried that, or is there any research going in that direction? No.
We did try just with the shrinking, with the process shrinking, but no, as far as I know, there has been no work being done in that direction.
Okay, thank you. Maybe last final question. How is Joseph doing? Joseph was a faculty over here.
Well, I've been a little bit out of touch with him lately because of lockdown, and he's been over in he's been somewhere near where you are now. So I don't have a very up-to-date picture of him, but he was going quite well before. He needed to find some big application to run on his system, on his
Okay, thank you, Peter.
Yes, thanks.
Thank you, Dr. Peter, for that informative session on the space grid combination techniques for resilient extreme scale simulation. Now it's time for a tea break. I would request all our guests and participants to move towards the adjoining hall. I request the participants to kindly report to their respective venues after the tea break. The technical sessions for the day will be conducted in 2 venues parallelly, namely Multimedia Hall and the Sonia Lab. The session to be held in this hall will be chaired by Dr. Anand Harindran, will mainly relate to data analytics. The parallel session in the adjacent hall will be chaired by Dr. Siji Pearl, that will mainly relate to intelligent electrical system domain. I request all the participants to kindly report to their respective venues for their presentation. Help desk team seated outside this hall will give you the needed assistance for your queries. Thank you.
Hello, Peter. Myself is Danya from the Department of Computer Science. You have given a very good talk regarding the sparse grid fault tolerance, its applications. You have clearly shown your results. You have also shared your link towards your project, also explained about the future works. Thank you very much for your very informative talk. Thank you, sir.
You're welcome. My pleasure.
Okay, thank you.
Good morning, everyone. Welcome to the first technical session of the day. The session will be chaired by Dr. Anand Harindran. He is an associate professor and HOD of the Muthoot Institute of Technology and Science. He acquired his PhD from the University of Kerala, and he specializes in machine learning and algorithm. Now I call upon paper ID 47 to present a novel forward filter features selection algorithm based on maximum dual interaction and maximum feature relevance for machine learning. And please note, it will be a 10-minute presentation.
A very good morning to all. I am Anida, presently working as Assistant Professor in Computer Department of College of Engineering, Cherthala. My topic is a novel forward filter feature selection algorithm based on maximum dual interaction and maximum feature relevance for machine learning. These are the contents. As you all know, the feature selection plays an important role in classification algorithm, especially when the data set is huge in size. The aim of the feature selection is to select the subset of features that are relevant for the model prediction and removing the redundant features. Why this feature selection has that much importance? The optimal subset, selector subset enables the machine learning algorithm to train faster, and it can also reduce the complexity of the model and makes it easier to interpret. The feature selection methods improves the accuracy of the model if the right subset is chosen, and it can also reduce the overfitting. The feature selection methods broadly classified into three categories: filter method, wrapper method, and embedded method. In filter method, the selection of the feature is based on the relationship between the features, and ranking is done by the different measures like information theory, distance-based, or any other consistency measures. It has more advantages over wrapper method. It requires less computational cost, and the result is classifier independent. That is, the selected feature subset is independent of the machine learning algorithm. And the disadvantage is the selected features may not be optimal for a particular learning task. In wrapper method, different models are learned with a different subset of features and select those subset of features with high performance. The advantage of this method is it provides the better predictive accuracy than filter method. And the disadvantage is it is computationally expensive compared to filter method. Then embedded method is the third category, which bounds the benefit of both the wrapper and filter method. This section, I'm going to discuss about the principle of mutual information, as the proposed method is based on this concept only. Entropy is the fundamental measure of the information theory, and the information is the inverse of probability of occurrence. So entropy is defined as a quantitative measure of average information in a set. Here, h of x gives the entropy of the random variable x, and the mutual information Mi is defined in terms of entropy only. It quantifies the amount of information shared by the two variables in terms of entropy. Here, I of xy is the mutual information between two variables x and y. H of x is the uncertainty about the input x before observing the output y. H of x bar y is the uncertainty about x after y has been observed. The value of Mi can be positive, 0, or negative. In recent studies, researchers uses the concept of mutual information for the feature selection. In earlier studies, they uses two factors, that is maximizing the feature relevance and minimizing the feature redundancy. These are the two methods that based on these two factors, that is mutual information feature selection and minimum redundancy maximum relevance method. These are the objective functions used for these particular methods. And here the first term is the relevancy term and the second term is the redundancy term. Then these are the two methods, that is conditional mutual information and joint mutual information maximization. These methods consider three factors, that is maximizing the feature relevancy as well as the feature interaction, and it also reduces the redundancy. And these are the objective functions of these methods. Coming to the problem statement, the data set of large number of features may result in more training time for learning and inconsistent model prediction. So my objective is to develop a new filter-based feature selection method, which can consider three factors, that is maximizing the relevancy and feature interaction and minimizing the redundancy for the classification problems. The proposed method consists of 4 steps. In pre-processing, removing all the tuples with the missing values and encode all the alphanumeric features into numerical features. After that, the feature selection is carried out using this maximum dual interaction and maximum feature relevance method. Then the classification is done on this particular data set with this particular subset of features using the naive-Bayes approach. The performance analysis has been done by using two methods, that is taking the average classification accuracy as well as the ROC score. This part is a core part of this work, that is the feature selection method, which is known as maximum dual interaction and maximum feature relevance. Here, first of all, generate the relevant feature set SREL. This is done by finding the maximum MI between the input features and the target class. But this set may not be strongly relevant, may not be consist of strongly relevant features. So, because it only consider the dependency between the individual feature and the target class. Sometimes the individual features may have less or average dependency with the target class. Here comes the importance of feature interaction. Sometimes these two features, some of the features together can give more dependency with the target class. For that, find the interactive features from the relevant feature set, and this is done by finding the difference between conditional and unconditional mutual information. And we have added the feature Fj to this particular interactive feature set by satisfying this condition. And next we have to generate the redundant features from the interactive feature set. And this is also done by finding the difference between the unconditional dependency and conditional dependency with respect to the target class. Finally, we have to add the feature Fj to the redundant set if it satisfies the condition given here. The final feature set is obtained from removing those redundant features, that is SRED from the interactive feature set SINT. So we have obtained K optimal features from this method. With certain value of K onwards, the average classification accuracy of the model shows a stable value. This is a flow chart for this particular method, feature selection method. Here, initially, the F will contain all the features in the data set, and then initialize the selected feature set S and the relevant feature set, interactive feature set, and redundant feature set to empty. Then we have to create a relevant feature set. After that, you have to create the interactive feature set. This is the continuation of this flowchart. Here, we have to generate the redundant feature set, and finally the S we have to obtain the set S by subtracting SRED from SINT. This slide shows the algorithm of this MDI MFR. That is, this part is for finding this relevant feature set, and this part of the pseudocode is for finding the interactive feature set, and this part of the code is for finding the redundant feature set. Then coming to the performance analysis, for measuring the performance, I have used three popular data set from UCA repository, and these are the details of this data set. The programming environment used for this particular work is Jupyter Notebook. The libraries used are scikit-learn and pandas for filter selection, classification, and analysis. For performance analysis, I have used two techniques, that is average classification accuracy as well as ROC score. Here, the average classification accuracy is plotted against the number of features. This diagram shows the average classification accuracy of the breast data set. And from this diagram, my method MDI MFR outperforms other method if the subset S is greater than 9 features. And it also shows the stable performance from the feature 70, from the feature number 17 onwards. This is the average classification accuracy of Parkinson's dataset. From this diagram, it is very clear that MDI MFR is more stable and average classification accuracy is greater than 93.87% with a feature set of 15 or above features. I have compared my method with the existing popular method that I have already discussed. And this is for Musk dataset. Here, MDI MFR gives the better performance in terms of average accuracy and stability with a subset of more than 25 features. And next thing I have used is the ROC score for measuring the performance. And this table shows the peak values of the ROC score for different feature selection method for different 3 data sets with different feature numbers. Here, the last row shows the values, ROC scores corresponding to MDI MFR, which gives the peak values except for the Musk data set with 10 features. For that case, it shows the lowest value, but in all other cases, the MDI MFR performs well. As you all know, this research and studies continues. The feature selection still become an open and challenging problem in the various fields such as machine learning, pattern recognition, bioinformatics, natural language processing, etc. Here I proposed a filter-based feature selection considering all the factors, that is maximizing the relevancy and interaction, and at the same time minimizing the redundancy also. And from this performance, from this work, it is very clear that MDI MFR outperforms other method in terms of average classification accuracy as well as ROC score. And it also achieves good stability in average classification accuracy from a particular value of K onwards. Further improvements can be done by identifying the higher order interactive features and also applying parallel computation strategy so that this algorithm can be applied on a higher dimensional data set efficiently. Before I conclude, I would like to thank my guide, Dr. Shirley KK, for her great support. Once again, thank you all. These are my reference.
So was a good presentation. So feature selection is one of the most prominent thing that we basically come across while we are doing any machine learning task. And your results shows that the kind of features that you have selected have given you a better performance. But I have seen, can you go back to the graphs of that Parkinson's? Next one. No, the next one is, yeah. If you see here, you can see high peaks and high dips in the first half.
Yeah.
So can you just justify why that particular happens while you select the features according to the proposed algorithm? Okay, you have given a particular algorithm. After a particular feature, number of features, that's actually giving you a very good result. But in the primary stage, you are having high peaks and high dips.
Yeah.
So there is a particular justification. We need to have a particular justification for that. So can you please try to do?
Actually, for smaller number of features, here every algorithm shows some fluctuations.
That actually has a particular
Actually,
term.
this data set is with 129 features. Out of this, I have selected, my method is selected 50 features. Actually, this graph shows the maximum number of features as 50. And from 25 onwards, it shows the stable result. But below that 25, it shows some fluctuations. That is every selection method is also shows this fluctuations.
Yes.
Maybe
what I was asking is that has a particular justification that is being given on almost all the algorithms. Okay, so there is a technical term behind that. So I'm just asking whether you know that.
maybe all these algorithms uses the concept of mutual information only. But
one more thing, in the minimum redundancy, maximum relevance algorithm, that formula you have shown, can you just mention which was the relevant term?
okay.
I think it was in page number 11.
Okay.
Which was the
Here,
relevant term and
minimum redundancy, maximum relevance method. Here, the first term is the relevant term, and the second term is the redundancy term. Here, the second term is only the difference with the first method is second term is divided by the number of selected features. Second term is the redundancy term, and the first term is the relevancy term, that is maximizing. Here the maximization strategy is used. This is the objective function. This objective function uses the maximization strategy, maximizing the relevancy term and then subtracting the redundancy term.
okay. Okay, as you have proposed a new algorithm, and I'm very much familiar with the algorithm area. So have you done any complexity analysis of the algorithm?
It will require order of n square, where n is the number of features.
Okay. Order of n square.
Order of n square.
Also, one last question. Yeah, one more. Can you go to that problem statement? Okay, data set of large number of features may result in more training time for learning and inconsistent model prediction. So for this, you are basically trying to gather those features which are more relevant to your problem, right?
Yeah.
Okay, so in a first loop, what happens is, or in a first loop, what the audience will feel like is, data set of large number of features may result in more training. So we need to reduce the number of features that is being taken.
Yeah.
So actually what happened, if I am having say 20 different features, all the 20 different features will be relevant to that. Okay. So in the first look, we feel like, okay, we have 20 different features. I need to take only 5 from that. Okay. So that type of that ambiguity in that particular statement was there. So just try to modify when you try to present this in the other place. Okay.
Thanks.
Okay. So that's all. That's all.
Thank you, sir. Once again, thank you all.
Next, I call upon paper ID 53 to present age and spoof detection from fingerprints using transfer learning. Please note it will be a 10-minute presentation.
It's already sent to the mail. Should I connect it again? Yeah. Oh. Yeah. It's okay. Download it. Thanks. Good morning, sir. So I'm here to present a paper on age and spoof detection using fingerprint biometrics. We have used transfer learning in this. So I am a faculty in SEMS School of Engineering and Technology, and Navneet Ashok and Nandu Shaji are my students. We have done a project in the area. So first of all, talking about the introduction, as we all know, biometric technology involves the identification and verification of individuals by analyzing the human body. Basically, it's a biometric metrics so that you can identify people. So many works in this area have been done where fingerprints are taken to identify who it is, to authenticate who the person is. So a fingerprint is a representation of the epidermis of a finger. It contains a pattern with all the ridges and bridges, and the distance between the ridges will be taken as a features that will be unique to person. So due to immense potential of fingerprints as an effective method of authentication, an attempt has been made in the present work to analyze their correlation with age of an individual and also to check for spoofing. So in this paper, we have just tried to find out the age. When we get a fingerprint, we have tried to find out the age from that, as well as whether it is spoofed or not. So motivation for this particular project was to take, the importance for fingerprint was underage voter registration and underage voters have been coming into. So just to identify that, and it is basically used in crimes and medical field also. Attacks are also used, based on this fingerprint, just to find out, based usually on digital forensics. So objective of this particular paper was to detect age from the fingerprint biometrics using machine learning techniques, to identify the best scanner for capturing fingerprints, to differentiate spoofed fingerprints from the real, and to identify the spoofing material used. What was the material? By the papers and by the literature survey we did in this area, we found out that there are many methods where spoofing can be done based on the material. There are some materials on which it can be done, as well as the scanners also gives us a different idea.
So literacy survey, we have just taken 3 papers. Out of the main 3 papers were, the first one says to organize and classify soft biometric attributes and enumerate the highs and lows of them in the real world. The second one says Anand K. Jain in the fingerprint recognition of young children. We just because we have taken age into account, we took the paper based on these young children to analyze the salient features of fingerprints of children and to check if they were used in reliably. Then the third paper also says about the biometrics in age and aging. Studies in the effect of aging. Whenever the age comes out, whenever the aged person is having some diabetics or something like that, even that in that case also fingerprints have a major role in not identifying the or not giving the correct result for authentication. Now the existing system is that you can identify a person, whether that you can authenticate a person, whether it is there or not, and very less work has been done in finding out the spoof detection as well as the aging of what category this the person is, or a particular fingerprint if we get the sample, in which age group that particular person is. So that is all about the existing work. In the proposed work, we have tried to compare age classification in these 3 models. First one is on these 4 models. One is CNN using the VGG 19, inception V3 exception, and the local binary pattern model. In this 4 models we have taken just to find out or just to compare how this age can be classified better. And one more additional feature we did here is that spoof detection and spoof material detection only using CNN, and LPB was used. Now, this is a proposed method, the very basic method where the input image was given, a pre-processing was done, feature extraction was done using the CNN, training model was done, it was stored, and in the testing phase, as usual, it was checked. A new model, whenever it was a new fingerprint, when it was given, using this model, it was classified in which age group it is coming. Now, the data set which we used here was, we just initially tried with the original scanner, but we couldn't find out, the scanner was not so accurate, we couldn't get the data. So we got a database from NIST special database. These are used for basically projects for initiate. It's already done there, and it is already classified, and it can be used for projects on special request. And 3 different scanners were taken from that. Michigan State University Raspberry Reader and Crossmatch as well as Greenbit. All these scanners, these are 3 different scanners from the database which we took. The data set we had categorized into 4 categories: age between 18 and 30, age between 31 and 40, 41 and 50, and greater than 50. And this is a distribution of samples in the data set in the age group of, in the first data set, that is Raspberry Reader. In that particular scan, the samples taken based on that scanner was the first one. Age group was taken, and almost very less samples we get in that. That is the only difficulty we found in this main project. For the spoof detection, we got a lot of things were there. Lot of data set were the liveness data detection competition live det 2013 data set was taken, in which there was 1,200 live samples as 1,200 spoof samples also. And in this spoofing material detection, in the same sample set itself, we got 400, all those 1,200 samples were divided based on the material. So using the latex, that is a rubber latex, data were taken, as well as play dough and as well as wood glue. On wood as well as on the silicon material and on the latex material, we got 400 samples each, which we took for classification. In the pre-processing, basically in the pre-processing step, the fingerprint was taken. All the images, whichever samples we took from the data set, was resized to 300 by 300 pixel height and width to in the pre-processing state, and it was normalized. The basic, it was not so clear, so some enhancing methods were done so as to just normalize it so that the ridges and the patterns in that was clear. Now, as I said earlier, that the data set had a very little data in it, only 75 samples from each and every, maximum 75 samples we could get from each data set in that already taken NIST data set. So the problem was that machine learning techniques were not so accurate in that particular sample set. So we tried a new method known as the data augmentation. We took a small patch. I'll just discuss how it was done.
2 more
The
minutes.
first one, yeah. The first one is the original sample. Can I come? The first one is the original sample. From that, a small patch was taken, and this patch represented, and we just reversed it back so that we can take n number of samples from each and every. So convolution neural network was used, the inception model as well as the exception model. Even the local binary pattern were taken. Going directly into the results, whenever the scanners were taken without augmentation, we tried with classification with augmentation, without augmentation, based on the scanners as well as based on the material that was used. Age detection without augmentation for all the data sets taken and all the models used, we got a percentage of, that is, cross match gave a good value for VGG 19. All the others were very less. With augmentation, again, it was increased and we could find out a pattern. This is only for research purpose. Augmentation, basically, it is not valid, but this was for research purpose only. And the results with augmentation, just a comparison about how putting all the other two together. Just a graph of how this was taken with augmentation and without augmentation. And the accuracy for spoof detection also, VGG 19 gave a better accuracy. And the conclusion, even now, this is used basically whenever how data augmentation has a role in this. That was also shown here. And a spoof detection, we could find out because the sample set for the spoof detection was much bigger. So we could find out a better result giving in VGG. Only the models were compared and we tried to get the spoof detection done. So these are the references. And thank you, sir.
It was a very interesting work. Can you just go back to the result? You will just skip. Next one. You were basically dealing with 3 types of spoofing material, right? 3 types of spoofing material.
Yeah.
Play-Doh.
Play-Doh, wood, and latex.
Latex. Okay.
So in the spoof detection, actually, we couldn't get that time. So in the spoofing material detection, cross-matcher scanner only was taken. Okay. And from that, we have not discreted that material. Okay. But basically, when we found out, latex was giving a better, because it was very clear, better than glue as well as Play-Doh. The latex material, the fingerprint on the latex was much more clear. We could normalize it much more, better than the other two.
Okay. I was just having some queries like.
Yes, sir.
So what was the actual output size from the particular fingerprint scanners?
Output size was of different sizes because it was not 300 by 300. Some was 300 by 300. Some were more than that. Some was enlarged. All those data set was differently done.
Okay, so
because it was,
you were normalizing that to 300 to 300.
Yes.
So was there any sort of distortion or some sort of feature?
Some loss was there. That is why we then normalized it. But we just, when we analyzed through the naked eye, when we analyzed, it was not so much of difference was coming out. Only the area which we took, that was cropped, and then it was put into 300. We couldn't, means there was not much distortions because we didn't have to reduce. There were many things which we had to expand. So yeah. Okay. So not much of the loss was there.
Okay. So normally in any sort of medical data set or image, we used to do augmentation because of the reduced number of data set that we are having.
Yes, sir.
So for a research purpose, I think the augmentation results was also better.
Yeah. Yes, sir.
The other
A
one,
little,
tape,
yeah.
tape, tabular.
The blue one is the with the
Okay,
augmentation.
Okay, fine, fine. One more thing. Okay, you told that while using our normal fingerprint scanners, you were not able to get the
Yes,
data.
sir.
So what exactly was the issue?
The issue that basically we didn't get a scanner. We usually have the scanners on the laptop, or we just tried some apps also, but it was not so clear, and we couldn't get a age group of very small size as well as a very on the upper than 70, 60. So we tried with our people at home, but the data set was too small.
Okay, fine. Still, you could have got a fingerprint scanner from anywhere around, right?
Yeah,
So,
that was because we did this project using the in between that COVID time. So
fine,
it was during that lockdown period. So no, we couldn't get it hardwarely done because
Yeah.
we have a fab lab at our college. So we just tried. We were planning to do it there, but the college was shut down. That's
yeah,
why.
sure. And one last question, other than what was the basic pre-processing that you have done other than making the ridges?
Basically, we didn't need much more. Only the noise was removed.
Okay.
That was enough. That is what I said, sir. Basically, we had to just shrink it.
Shrink it to the particular.
Yeah.
Okay, thank you.
Thank you, sir.
Next, I call upon paper ID 69 to present semantic Malayalam dialogue system for COVID-19 question answering using word embedding and cosine similarity. Please note it will be a 10-minute presentation.
Good morning, all. First of all, I would like to thank for giving me this opportunity. I am Liji, research scholar from SS College, Hierarchical under Calicut University. My research area is natural language processing. I am working in Malayalam question answering. This is semantic Malayalam dialogue system for COVID-19 question answering. Human-computer interaction is a mission of mankind since the development of modern computers. The interactions between computers and humans is achieved by artificial intelligence and natural language processing techniques. This is a Malayalam dialogue system for COVID-19 related question answering. Human-computer interaction is achieved by using dialogue systems. Also nowadays, a huge number of in the situation of COVID-19, huge number of people engaged in web searches, especially for natives, the authoritative and correct information access is very difficult. It is a main motivation behind this work. Dialogue system is a conversational agent which can communicate with people via text or other means, that is speech. This is a semantic dialogue system to deliver accurate and relevant answers to users' queries related to COVID-19 diseases. The system accepts the queries from the user and analyze the query and match it with the available documents, then retrieve the most relevant results for their queries. From my literature review. I reviewed different information retrieval and question answering systems. Different approaches to question answering are pattern matching approach, linguistics approach, and statistical approach. From this, linguistics approach is more efficient. These are some methods noticed while my review. These different methods used are word embedding, word-to-vec, fast text, deep LSTM, graph embedding, Coreference, query expansion. But these are different methods. From the literature, we notice that there is no effective question answering system in Malayalam exists till now. Different works are done in other languages like English and other languages, but the question answering systems in native languages, especially in Malayalam, semantic question answering, there is question answering, syntactic level question answering systems are also exist, but semantic level question answering system not exist. In semantic level question answering system, the context and meaning of the document also considered. In our work, we use word embedding to take contextual informations. About our data set, we collected different data set from TDIL, Kerala.gov.in, health.gov, dataset, etc. First of all, we annotate our data set in the squared format. Stanford University question answering data set, we annotate our Malayalam data set in that format. There is no data set available in Malayalam, so we create our own data set. These are some questions taken from our data set. Endana COVID-19? These are the data sets in annotated format, in JSON format, or we can download as in Excel format. There's a question answer document. This is the architecture of our system. Different steps are pre-processing, feature vector creation, and document retrieval. Pre-processing is a very first step of every NLP applications. We use main techniques: tokenization, stop word removal, and lemmatization. While tokenization, we divide the text into documents into individual tokens or words. While stop word removal, remove unwanted words. During lemmatization, take the lemma or root form of the word. Then document modeling, create a feature vector and convert the document to vectors as vectors. Here we use word embedding, word-to-vec algorithm, SIBO and skipgram. SIBO is continuous bag of words, skipgram. SIBO predicts the words from its context or surrounding words. Skipgram predicts the surrounding words from the target word. This is the word embedding for our questions. We get a value, fractional value. It also considers the semantics of the word also. This is a representation of words, vector space representation of our words in question documents. These are the words taken from answer documents. This is the vector space representation. Then finally, retrieve the relevant answers by using cosine similarity. The similarities between queries and documents is calculated by using cosine similarity. Cosine similarity angle between the queries and documents. Higher the value of cosine similarity means more relevant the document. These are different steps: pre-processing, convert the documents as vectors, compute cosine similarity, rank and retrieve the result. These are some results taken from our experiment. These are some results. Coronavirus ലക്ഷണങ്ങൾ എന്തെല്ലാം? What are the symptoms of coronavirus? This is the corresponding answer. പെട്ടെന്നുണ്ടാകുന്ന പനിയും ചുമയും അല്ലെങ്കിൽ പനി ചുമ. These are the answers we already annotated in our data set. About the analysis of our system, the average of top 10 cosine similarity, average of cosine similarity of top 10 retrieved results are shown. Then F1 score. F1 score is the harmonic mean of precision and recall parameters. In our experiment, skipgram shows higher F1 score value. Skipgram is more efficient than SIBO in our data set. About our future work, we develop a question answering system in any health related questions. Also plan to integrate more efficient features like BERT, etc., transfer learning, etc. Now I am working in BERT also. Thank you.
I have a small query, like, have you deployed this for the public use or you are just done in a prototype?
No, now not deployed. Plan to.
Okay, so this is just a mapping of the questions and answer using the cosine similarity, right?
More than cosine similarity, we use word embedding. It's a 3-layer neural network architecture. We take a pre-trained model and fine-tune with our data set. Then the system can answer the questions other than the questions from our data set, trained data set.
So what was the accuracy level for those questions that is out of your particular database?
Accuracy under 80.
18. So when we are doing such sort of projects, it's better if you deploy them, you can actually see what happens in real time. Okay, what are the sort of questions asked, because the type of question will be changing. Okay, in the first phase of COVID, okay, the initial questions will be what are the symptoms, etc. Then it will be changing to say, what do you mean by cluster? What do you mean by mini cluster? So the questions keep on changing. So I think if you have deployed this, you could have got some more data, and in which way you could have basically done when the real-time questions comes.
Sir, so, first of all, we can map a question to question. User, while user typing a question, we can match a question.
Yeah, well,
like prediction.
If it was there in your database, right? So I was telling about the other portion. Also, have you used any sort of web crawling tools for analyzing the data from the various data sources?
Scrolling.
Web crawling data or a web crawling tools or something for getting data from the various sources? No. Okay, that's all. Thank you.
Thanks. Oh, it will answer. Yes, yes. By using word embedding, we take the words. No. It's not. Also consider the semantics. By using word embedding, convert the words as a fractional value. Like apple and orange, both are fruits. but both of them are different values in the according to a context. The value of apple is more close to a company's name or a electronic device name, but orange, it doesn't matter. It's identified as a fruit. Yes.
Also, F1 score is calculated. The accuracy value, such type of values may be required for your surface addition.
Okay.
Also, there is a candidate of navigation. Yes, sir. So, and also if they issue on this particular.
Okay, sir. In the final stage, we perform different steps to increase the accuracy of our model. Thank you for this.
Next, I call upon paper ID 91 to present attention span detection for online lectures. It is an online presentation. I call upon paper ID 91 to present attention span detection for online lectures. Please note it will be a 10-minute presentation.
Yeah, am I audible now?
Yes, you're audible.
Okay, yeah, okay, I'll start now. My presentation is also visible there. I'm not able to see that.
No, you're not visible.
Okay, I'll share my screen.
No, you're not. Can you share your screen?
Okay, I'll share my screen. Okay. Just give me a minute, I'm sharing the screen. Is it visible now?
Yes, it is visible, and you may start.
Okay, thank you.
And please note it's a 10-minute presentation.
Right. Sure. So good morning to everyone present online and offline mode. So the topic I'll be presenting today is attention span detection and lecture management system. In this pandemic, we saw that more than 1.2 billion kids were out of school and they were enrolled through online mode of teaching. So because of this, the teachers were not able to keep track of whether the students were paying attention or not. And they were, unlike in the classroom situations where the teacher was able to gauge whether paying attention, who's sitting in the third bench in the second row. Such type of provisions are not allowed in online mode of teaching. So due to this, the students also lose interest in learning sometimes, and teachers also, need to know whether the student is paying attention or not. So online lectures do not equip the teacher who is teaching to monitor the student in real time to make sure that the students are paying attention. And so what we are trying to do is we are quantifying the attention of the student with the help of camera, microphone, and various other technologies. We are trying to estimate whether the student is paying attention in the whole class. So quantifying the attention of the student will not only help the student, but also the teachers to alter their teaching pattern based on the attention given by the students. So for example, if a student is not paying attention, whereas the whole class is paying attention, so it means that the student will also be encouraged to pay attention, looking at the average attention of this class. The vice versa, the same goes for the opposite also, where no one is paying attention. Then it means that teacher will have to do in whatever is in her power to keep the lecture more interesting. So this will be a win-win situation for both the teacher and the student. So let's come to literature survey. So in a lit survey, we found that some authors use the OpenCV and Viola-Jones face detection algorithm to measure the human attention. But what they noticed was it had a lot of false positives because OpenCV is trained on positive and negative images and not exactly on attention and not attention images. So this had a lot of false positive, and it also did not address the issue of whether if the student is looking down or he's looking left, still he's paying attention. In that case, it was not taking the attention into account, and it was characterizing it as not attention. So the second was the taxonomy of external and internal attention. So this was a very good paper where the authors, presented all the various things that were available and which could be used to, measure the attention of the students. But this was mostly based on research process, and it had like little implementation and close to no results of each method. The next was the monitoring attention in a classroom using computer vision. So this was in an offline classroom situation. In this classroom situation, they installed a camera in the class, and they saw how the students were tilting their head, and if a teacher is moving in the class and all the students are moving their head according to the teacher's direction, then it means that they are paying attention. So using all these psychological techniques, they were trying to determine the attention in an offline classroom. The next was the students' attention assessment and e-learning based on machine learning. So this was close to what we are doing, but the only thing that they were doing was they were only looking at the eye of the student. So they were segmenting the eye from the whole face, and they were determining whether where he is looking, whether the eyes are closed or not. Based on that, they were determining the attention. The next one that we thought was worthy of presenting here was the predicting students' attention in the classroom using the Kindnect 1 sensor. So Microsoft provides a Kindnect 1 sensor, which has various things like the motion and the head rotation and all those things they capture. This is also an offline mode, and using that, they determine the attention. So according to the lit survey, we understood that what we are trying to present is, some of them are presented, but not the whole thing what we are trying to do now. I'll talk about the methodology. Yes, initially we thought of using unsupervised learning, where we thought of training the data on using the unsupervised learning to form individual classes itself. But what we found that the data diversity was so large that the accuracy dropped significantly. So, if a student is wearing a particular blue color t-shirt, then all the classes were determined into a blue color t-shirt, not exactly attention and not attention. So the next thing that we thought was to resorting to manually labeling a data set. And this made perfect sense because in a classroom situation, teachers know who are paying attention or not by looking at their face, what they are doing in the classroom, etc. So we gave that responsibility to teachers itself to label the data set based on their interpretation, whether the student was paying attention or not. So this proved effective in the aftermath also when we were trying to train the model. So our initial research showed promising results with using Postnet for video classification. So Postnet, what it does is it marks 17 points on the whole body, and based on that, it determines the pose of the man, how he's sitting, whether he's slouching. As you can see in the image, you can see that in the top portion, the student is sleeping. He's having his head turned to the right, and he's talking on the phone. In all these cases, it can be classified as not attention. Whereas in the bottom half, we can see that all the three students are straight, sitting straight, erect, and their eyes are focused on the screen. So you can see that they are paying attention. So what we tried to do was to implement a multi-class classification with 3 classes, which is not present, not attention, and attention. So not present also we try to include because if no one is present in the lecture, then it means that attention is of course 0. So it is worse than paying not attention because no one is present itself in the lecture. So we try to implement into 3-class classification. And so due to unavailability of data, we collected our own data sets because in this COVID pandemic, we found that there were a lot of YouTube videos of classes and etc. which were uploaded for free. And so we tried to extract images from them and then give it to the teachers to label it. So we also implemented an audio noise detection. So I'll explain that in the next one. Yeah. So this is our basic workflow. What we try to do is we have the video and the audio detection. In the video is the Postnet classification, which estimates whether the student is paying attention. If it is not attention, then we have a confirmation page where we can address whether he's really not paying attention or he's putting his head down and still he's paying attention. That we can do to some extent using the notification quiz for regaining attention of the student. So I'll explain that, and now let's move to the audio one. So audio, what we are trying to do is we are trying to segment the background noise and trying to estimate whether there is any speech detected in the background noise. So let's say, for example, a student is sitting in the lecture and he's talking to some other people in the neighboring room or something. So in that case, he's of course not paying attention. So in that case, what we try to do is we drop the attention value score by 50% if speech is detected. Whereas if other noise is detected, let's say there is some dog barking in the backside, or there are some siren voices or construction voices. If we find that in the audio extraction, then we reduce the attention accordingly. Like for 10%, if some other dog is barking or something like that, we reduce accordingly based on the noise which we find. So we also try to implement this in our system. And yeah, so now let's get back to the notification quiz. So from a literature survey, we found that most of the people are not able to gauge the attention when the student is closing his eyes or he's not he's looking left, right, and still paying attention. That becomes a technical limitation of the cameras and the microphone. So we are trying to implement that also to some extent using the quiz function. So what we do is in the beginning of the lecture, we give the teacher the ability to enter the quizzes on the topics which he or she will be teaching in that lecture. And based on the completion of that topic, he or she will have the option to release the quiz. So using this, if the system detects that the student is not paying attention or not present in the frame, then in order for extra confirmation, we pop a quiz regarding the topic which was taught in that particular time period based on the teacher's releasing of the quiz. And if the answer he gives the correct answer for that quiz, it means that he's paying attention, but still he's not looking directly to the screen. So using that, we try to incorporate that technical limitation to some extent. And if he gives a wrong answer, then it means, of course, the system was correct because it already predicted that he was not giving attention. So this was the whole system that we designed for the classroom, which could easily be, completed using a simple camera and microphone. So coming to the results, the model collected was validated by the validation set, and the accuracy was around 80% over 100 epochs. The maximum validation accuracy reached was 83% for 100 epochs. As the model trained more than 30 epochs, the validation loss of the model increases due to the problem of overfitting. So to overcome this overfitting problem, we try to incorporate early stopping callbacks, which automatically stops the system whenever the accuracy is plateaued. So using all these things, we try to estimate the attention of the student. So, our system was built on the principle of ensuring that the sanctity of the classroom environment is maintained during an online lecture. After complete this project, we can confidently say that if requirements of the internet connection and camera is satisfied, then the gap between the classroom lectures and the online lectures is reduced to a great extent. If not still completely, at least the teacher is able to get an idea of what the attention of the student is and what is the attention of the whole classroom. So during this pandemic, any kind of improvement in the current online lecture setup will be appreciated. Yeah, so this was a paper. Yeah, thank you. I'm open to any queries. Yeah.
Hi, Senthil.
Hello, sir.
Senthil, we can have a lot of debate on the topic that you have just presented. Okay, so I just need to know two things. Have you used what were the parametric and non-parametric features that you have been selecting?
Okay, so the features that we selected was, the pose 5. It consists basically of the 7 points of the Postnet: 2 eyes, 2 ears, 2 shoulders, and 1 nose. So based on this, the Postnet system determines the pose of the student, how he's sitting, where he's looking. Based on that, we estimate the features and the attention.
Okay. Have you done a real-time analysis on some of the data sets? And what was the size of the data set? I would like to know that.
Okay, sir. So we, as I mentioned earlier, we got the videos from various sources, and we extracted the images from that, and we incorporated about 1,500 to 2,000 images in the initial phase to determine whether the system can work or not. And still the results were appreciable.
Okay. Also, one last question. You have told that when someone is not engaged in the class, or if he's not attending the class, a quiz will be coming up, and if he gives the wrong answer, it will be showing like the attentiveness is less. So what happens by choice if answer gets correct?
By guess you are asking, sir?
Yeah.
Okay, sir. So in this, see, first of all, this is a technical limitation that we experienced early on. So we try to incorporate it as much as possible. So such guesses and all, that will of course affect the system, but we are trying to incorporate that in the true sense. Yeah.
Okay, sir. That's all from me.
Thank you, sir.
Hello.
Hello.
Yes. I think you have used the Postnet network.
Yes, sir. That's right.
Okay. Which database that you used in your work?
Okay, sir. So the data set that we have used is we have extracted images from online lectures and the freely available sources. There are various classes on YouTube. So using that, we extracted each image from those videos and then we gave it for labeling. manually labeled.
Whether the Postnet network is developed by you or it is already available.
Okay, sir. So Postnet is a pre-trained model, and we are trying to train that on our own data set. So the initial implementation is there, but it can be curated according to our own data set. So, this paper is present on the whole overall the system, not, exactly the Postnet one.
Oh, okay. One more thing is that it's a practical limitation. You need to install this particular system on student computer, isn't it?
No, sir. No, actually, this is a website. So, anybody can access the website if they have, there's a student login and there's a teacher's login. So, everything is done on the client side. So data is not sent anywhere. So, it's not a system or software that you need to install. It's just a website for at least the initial
Which means you need a separate platform for this.
No, we can separate platform. I didn't get that.
My question is that nowadays all the classes are going on like Google Meet or Zoom or something like that. So
right.
Whether it is practically possible to install this particular system with Google Meet or Zoom or some such type of platforms?
Right. So, Google Meet and Zoom, they are not, so we cannot manipulate that. But of course, in school, college level or school level, we can create a software and distribute it to the students for their use.
That means the students should install this particular system on their computer.
Right. So, as I mentioned earlier, sir, in the initial stages, it is a website. But when the load increases and there are many students who are enrolling, you need to have a software so that it is more convenient.
Okay. Similarly, one more suggestion in your logic diagram, whether after the quiz or question, something like that. Yes, notification were quiz for regarding attention of student. If it is correct answer and wrong answer, it is again going back to video. I think there is no need to classify whether it is correct or wrong.
Okay, so you are suggesting that only if the student answers that question,
yes,
it
answer,
means that
whether
he
it
is
is
giving
correct
attention.
Correct or wrong, there is no need to mention that one.
Okay. So, but it might happen that if a student is busy in his mobile phone and he sees a pop-up of the question and he just marks it, and again he's on the mobile phone. So
no, you are
in
not.
That case,
you are not evaluating whether the answer is correct or wrong in this particular system.
No, sir. We are actually evaluating in the backend. So this quiz
if it is correct or wrong, you are again going back to this particular video in this particular logic flow diagram. I think in your logic flow diagram, you can correct that one, like whether it is answering the question or not.
Right. Okay, sir. We'll include that in the logic diagram. Right.
Okay. Thank you. That's all from my side.
Thank you, sir.
Next, I call upon paper ID 108 to present conference resolution for ambiguous pronoun with BERT and MLP. It's an online presentation.
Hello. Am I audible?
Yes, you're audible now.
Let me share my screen. Can you see the screen?
Yes, we can see your screen.
Good morning, everyone. Firstly, I would like to welcome you all to my conference, to my presentation on Coreference resolution for ambiguous pronouns using word and NLP. My name is Anand Harindran, and I am from Amritsar. And today, I will be presenting our work on behalf of all the authors. And starting with the introduction, Coreference resolution for ambiguous pronouns.
Your voice is breaking.
Is it okay now?
Now it's better.
Yeah. Coreference resolution is one of the major challenges in the field of NLP. And it is used in various ways, such as document summarization, machine translation.
Excuse me.
Yeah.
Some noise is there. Can you correct your mic?
What about now? Hello?
Okay, you can start.
Coreference resolution is one of the major challenges in the field of NLP. And it is used in various fields such as document summarization, machine translation, question answering, and etc. One of the important applications is semantic search, where we can understand the mood of the people, and based on that, we can recommend the solutions that they require. And it also helps us to helps machines to understand the human languages way better, and which in turn helps us to deliver the services with a greater accuracy and high efficiency. And what is coreference resolution? Coreference resolution is nothing but a task of finding all the expressions that refers to the same real world entity in a text. Let us see this with the examples. Ram and Namita are good friends. He asked her to come to his house for his birthday party. Here, initially, we are just identifying the nouns and pronouns, and then we are mapping the pronouns to the respective nouns. This may seem a bit easy, but if we consider the next couple of sentences, we need to understand a clear-cut you need to have a clear-cut understanding of the whole sentence. He poured water from the pitcher into the cup until it was full. He poured water from the pitcher into the cup until it was empty. So here, in order to map it to the particular noun, you need to have a clear-cut understanding of the whole sentence to map that. And what are the steps performed in coreference resolution? There are two steps, namely mention detection and clustering of mention. In mention detection, you basically identify the nouns and pronouns. In clustering of mentions, you map the pronouns to the respective nouns. And there are some important terminologies in coreference resolution. One of them is anaphora. Let us see this with a few examples. Rosie is a dancer. She has chosen dancing as her career. Here, firstly, we identify the nouns and pronouns. So here, Rosie is a noun, and she, her are pronouns. So here, as the noun Rosie is preceding to that of the pronoun she, her, so the Rosie becomes antecedent, whereas she, her, the pronouns becomes anaphors. Whereas cataphora, it is quite opposite to that of anaphora. Let's see this with an example. To meet his relatives, Andrew went to USA. Here, as the pronoun his precedes to that of the noun Andrew, so the pronoun his becomes cataphora, and the Andrew noun becomes the postcedent. And coming to the split antecedents, Ram and Sham are friends. They play badminton together daily. So here the pronoun they refers to both Ram and Sham collectively. So the pronoun they is called split antecedent. What are ambiguous sentences? These are the type of sentences which are not clear. Let us consider the example. Take the bag out of the car and get it fixed. So here the pronoun, we don't have a clear-cut understanding of to which noun the pronoun it is being referred to, which in turn makes the pronoun it a ambiguous pronoun, and that in turn makes the whole sentence an ambiguous sentence. And we have made use of Gaap Dataset to solve this problem. So Gaap Dataset is a gender balanced dataset it contains 8,900 label pairs of ambiguous pronouns and antecedent names, which were sampled from Wikipedia and are released by Google LMS. These are the 11 columns in the data set. And here is the link for the GitHub repository of the data set. And we have made use of BERT model to solve this problem. So BERT actually stands for bidirectional encoder representations for transformers. It is since BERT is a bidirectional, it can understand the context of the token from both right and left hand sides of the sentence. If we consider the few examples, we went to the river bank. I went to a nearby bank to make a deposit. In order to identify which bank, we need to have a clear-cut understanding of the whole sentence. It may be either the river bank or it may be money bank. BERT architecture actually has two types. One is BERT based and another is BERT large. In BERT large, we have made use of BERT large since it has 24 layers, 1024 hidden units and 340 million parameters, whereas BERT base has only 12 layers, 768 hidden units and 110 million parameters. And coming to the multi-layer perceptron, we have made use of multi-layer perceptron for a multi-class classification purpose. And multi-layer perceptron is a feed-forward artificial neural network. It contains at least 3 layers, an input layer, hidden layer, and an output layer. We are making use of an MLP with 4 layers, or one is input layer and 2 hidden layers and an output layer. We have decided the number of hidden layers based on the trial and error method. When we try to increase the number of hidden layers, the complexity of the model increases, which in turn increased the memory usage and computational power. And when we decreased the number of hidden layers, we were not able to achieve the results up, good results. And we have made use of activation functions at the hidden layers, and the input and the hidden layers are batch normalized, and a relay activation function is applied. And at the output layer, we have applied a softmax activation function. And coming to the proposed design solution, when the input data is processed to the pre-processing techniques such as tokenization and various custom insertion of various custom tags, and this pre-processed data is passed to the pre-trained BERT, which in turn gives us the contextual embeddings. And these contextual embeddings are passed to the custom-made NLP classifier. And using a snapshot ensemble function, we were able to select the model with the least loss score. And using that model, we were able to predict the probabilities of each class with respect to the target pronoun. And the class with the highest probability is selected as an output. And coming to the implementation, as I said earlier, the input pre-processed data is passed to the BERT, and then we were able to obtain the contextual embeddings, and these contextual embeddings are passed for the multi-layer perceptron for multi-class classification. And snapshot ensemble method is used to obtain the model with the low loss score, and which and that model is used for the prediction purposes. And here is the snippet of the training where we can see the snapshot ensemble method in action. So here we can see if the snapshot loss is lower than the previous loss, the snapshot and using snapshot ensemble method, we are taking the new low. And then, as I said earlier, we are using the softmax activation function for multi-class classification. And coming to the results and discussions, here is the snippet of the output file that we obtained. Column A and column B here contains the probability value which determines whether the output belongs to antecedent A or antecedent B. And column neither represents the probability that the output belongs to neither class A nor class B. The class with the highest probability value is selected as output. And then coming to the proposed model performance on the Gaap dataset, by using BERT large model in inference with deep speed and using multi-layer perceptron classifier for multi-class classification and using some hyperparameter tuning and using weight decay, we were able to achieve an accuracy of 80.45 and a loss score of 0.5926. And here is the comparison of our work with other existing solutions in this area of work. By making use of BERT large and MLB, we were able to achieve an accuracy of 80.45 compared to the other existing models in this area. And I hereby conclude this by saying that BERT large in inference with D-speed and combined with the MLB classifier for multi-class classification and using various hyperparameter tuning, we achieved an accuracy of 80.45. We also were able to reduce memory usage and computational power, and with the usage of snapshot ensemble method, we were able to select the model with a low loss score. And all this resulted in a significant improvement in results compared to that of the existing solutions in this field of work. And here are the list of references. And thank you for giving me this opportunity.
Hi. Hope I'm audible. Am I audible?
Hello.